Hi there, Mr. Sutton here, bringing you the IM3 Honors 3-3 lesson on dividing complex numbers. Specifically, we're going to be finding conjugates of complex numbers, and we're going to use that with some other tricks to help us divide complex numbers.
For your warm-up, is the following expression 7 over I simplified? Why or why not? And if it's not, go ahead and simplify it. All right, let's see what you came up with. So this is not fully simplified. The reason is actually kind of a throwback to our chapter on radicals. I, remember, is the square root of -1. We're not supposed to have square roots in the denominator. So for that reason, since it's a radical in the denominator, this does not count as simplified. So how do we fix that? Well, whenever we had a radical in the denominator, we just multiplied by that same radical over itself, and that took care of the problem. So let's see if we can do that here. If we multiply by I over I, let's see what happens. In the numerator, we'll have 7I. Denominator will have I squared. But I squared is really -1. So then we'll have just -7I. And that definitely takes care of the problem. Try this next one on your own. All right. Now, did you multiply by 4I over itself? Well, you could still get the answer that way, but you didn't need to. If you have an I down here, just multiplying by 1I over itself will take care of the problem. Because when you do I times I, you're going to get an I squared, and it doesn't really matter what's being multiplied by the I squared. It's just going to be negative version of that. So multiplying all this out, we've got 3I minus 5I squared all over 4I squared. 5I squared is -5, but we're already negating it, so that'll be a +5 up there, and a -4 down here. And there's not really much else we can do. This is as simplified as it gets. We're going to shift gears, or appear to shift gears a little bit, to talk about conjugates. Conjugates means we have the same numbers, same complex numbers, but opposite signs for the imaginary part. So, for example, a plus bi and a minus bi. See if you can identify the conjugate of each of the following numbers here. All right, let's see how it went. So for this first one, we just changed the sign of our imaginary number. That'll be 6 plus 7i. Over here, again, just changing the sign of the imaginary number. So that'll be -3 minus I. And for this last one, again, just changing the sign of the imaginary number. So that'll be -9i minus 8. Or you could also write this as -8 minus 9i. Now, technically, this right here is the conjugate of 9 minus 8. It's 9i minus 8. But if you went ahead and turned this into 9i plus 8, it's not the conjugate, but it'll actually still work for what we're about to do next. All right, so here's a problem that is a little bit trickier. When we just had a single term with an I in the denominator, multiplying by I would take care of the trouble. But let's see what happens here if we multiply by an I. Well, this would give us 4i minus 5i squared. So that's nice with the 5i squared. That's turning into a real number. But over here, now we're going to have a 4 with an I next to it. And then if you multiply by I again, well, you'll get 4i squared, but now the 5 will have an I next to it again. So there's no way to get rid of that pesky I by just multiplying by I itself. So how can we take care of this? You might remember when we were multiplying complex numbers, the only time you were ever actually able to end up with just a single real number as an answer is when you multiplied a complex number by its conjugate. So that's what we're going to do here. If you have two terms in your denominator, multiply by the conjugate of the denominator. Now in this case, that's going to be 4 plus 5i over itself. And let's see what happens if we do that now. I'm going to do the numerator first. For that, we just have to distribute the 12i to both of these. So that'll be 48i plus 60i squared. And in our denominator, using our squared, let's see, plus minus a squared minus b squared shortcut, we're going to end up with square the first thing, that's 16, square the second thing, that's 25i squared, and stick a minus in the middle. Now again, you are allowed to just FOIL this out. This whole a squared minus b squared thing down here is just saving us a little bit of time. So let's simplify this. We've got negative 60 and 16 plus 25. So that's going to be, let's see, negative 60 plus 48i over 41. And that's as good as it gets. So now that you know the trick, pause the video and see if you can wrestle with this last one on your own. Okay, let's see how it went. So again, we need to multiply by the conjugate of the denominator. There's two terms on both sides of the fraction, so you have to be careful here. We're going to multiply by 2 minus 4i over itself. Doing that for the numerator, we're going to have to FOIL these two expressions together. So that's going to give us a 2 for the firsts, then negative 4i minus 10i, and then finally plus 20i squared. For the bottom, we're going to have 2 squared, 16i squared, and then we're going to have a minus in the middle of those. Simplifying, up top we've got 2 minus 14i minus 20. Down here we're going to have 4 plus 16. Combining like terms, 2 minus 20 is negative 18. 4 plus 16 is 20. And as a last step, these are all divisible by 2, so we can simplify everything to negative 9 minus 7i all over 10. So that's it for this one. We are done with I, and you are done with me. Mr. Sutton, signing off.